And in this next example, we've got a little bit different scenario. We've got an amplitude now. Amplitude change, obviously you always have an amplitude, but you have an amplitude change, and we also do not have a factored argument. Okay, so we're going to have to put it in the factored form. So let's go through the same process. We find our period and our phase shift. Of course, the amplitude is there, and we can get that in a moment as well. And then we need to get our 5 key points, which really at the end of the day is the more difficult part of this graphing process. Okay, before I can get my period and my phase shift, I've got to get the factored form here. So let me take that off to the side for just a moment. Yeah, the 2x plus pi over 2. Well, obviously, my goal is to factor out the coefficient of the x. So I'm going to do that. And it's going to leave me with an x and a plus, and then something in the parentheses. And so what is that something? That's the question. What would I multiply 2 by to get pi over 2? Well, the answer can be found by dividing the pi over 2 by 2, right? Take this number, divide by 2, or multiply by the reciprocal, or however you want to view that, and you'll get the number that fills in the blank there. So if I take pi over 2 and divide that by 2, or again multiply by half, same thing, you'll end up with pi over 4, right? You double the denominator. All right, so pi over 4 would be the phase shift. Okay, and you can always again check this, make sure you factored it correctly. 2 times x is 2x, and 2 times pi over 4, well, 2 quarters is a half, right? So it's pi over 2, pi over half a pi. Okay. Okay. So now I can take and write this out in its factored form. Let's see, 2x plus pi over 4. Okay. Now there is one other thing that's a bit strange. I'll point it out as we go. Let's get our period in. Period is 2 pi divided by the b value, which is 2. And you cancel out the 2's, you get pi. So we have a period of pi. The phase shift is d. Now the d value in the formula has a minus. It's what's being subtracted, right? X minus d will shift the graph over to the right. Here I have a plus, right? It's a plus, not a minus. And so what ends up happening is you're really subtracting a negative. The double negative creates the plus here. So you could sort of think of this as x minus negative pi over 4, right? A double negative. And so what you're subtracting is actually negative pi over 4. That means our phase shift is not going to be to the right, it's actually going to be to the left, a value of pi over 4, okay? So that's our phase shift. Our period is pi. That gives us our starting point. Now we need to take the starting point. I'm going to draw out my number line. And again, you don't have to draw the number line out. It just helps me to visualize where all these numbers go, okay? So I've got a number line here. I know again that the total period is going to be pi. And so now I need to figure out what the jump is between each of my 5 key points. So this jump here, remember, is 1/4 of the period. Not half. 1/4 of the period. And remember to multiply a fraction by a quarter. Well, I guess, yeah, you multiply the bottom by 4. In this case, it's just pi, so it'd be pi over 4, right? So the period is pi over 4. Or I'm sorry, the quarter of the period is pi over 4. The period is pi. So what I'm going to do then is I'm going to take this starting point at negative, I'll write it up over here, negative pi over 4, and I'm going to add to that my quarter period, which is another pi over 4. Okay, my quarter period pi is the period divided by 4, okay? Well, negative pi over 4 plus pi over 4 is 0. So that gives me a nice value. I know I like that one. That's going to be right on the y-axis. Then I'm going to have, let's see, then I go start at 0 and add another pi over 4. Well, that's going to be pi over 4. Okay. And then I take pi over 4 and add another pi over 4. Well, that's 2 pi over 4. Well, what's 2 quarters make? Well, that's a half, right? So pi over 4. Or I'm sorry, pi over 2. A half. Alright, so that's pi over 2. And if I add a quarter to a half, I get 3 quarters, right? So pi over 2 plus pi over 4 is going to be 3 pi over 4. 3 quarters. This is 2 quarters and 1 quarter makes 3 quarters. So that's 3 pi over 4. Okay? So that should give us all of our key points as we go. This one's not going to be nearly as difficult to graph as the one I had in the previous video, because all of these quarter points, all of these 5 key points, show up pretty nicely on a graph if my scale is pi over 4. So let's create a spot here. I'm going to erase all my work on those 5 key points because I have them summarized over there. And now I can plot my graph. That's not very vertical. Let's do that a little bit better. I'm not sure that's improved. We'll see. Now in this one, we're starting on the left of the y-axis, so I need a little bit more space on my left here. Okay, so let's go with a quarter pi. So let's put pi out here somewhere, and then I cut that into quarters, so that gives me a quarter pi. Okay, so here's pi over 4, pi over 2, 3 pi over 4. So that's 1 quarter, 1 quarter, 1 half, 3 quarters. And then I also need my negative pi over 4, so I'm going to take that distance and try to get it roughly the same on that side, on the left. And there's my negative pi over 4. Okay, so now I have all my 5 key points plus an extra, which is kind of useless. I just used it to get my scale down. And then I'm going to try to plot this out. Again, the sine wave, the sine function starts at the axis, goes up, down, back up again. Okay, so we start on the axis, which means my negative pi over 4, the positive pi over 4, and the 3 pi over 4 are going to be my 3 x-intercepts. This graph goes up, but it goes up to an amplitude of 3, a max value of 3, and then down to negative 3. So let's go 1, 2, 3, and then negative 1, negative 2, and negative 3. And that should get us our next point. So at 0, that's my first quarter, I go up to 3. And then at pi over 2, that's my 3/4 point of my period, I'm down at negative 3. Yeah, that looks pretty square there. Okay. Now I just connect the graph. I should label those points. My intercepts, I'm not too worried about labeling the intercepts right now, but I think these other ones, well, this one here is obviously 0, 3. This one here is pi over 2 comma negative 3. And I think as long as your x-intercepts are right on the tick marks with the scale, I'm okay with maybe leaving the labels off because the labels start to clutter things. And then I can plot my 5 key points, or plot the graph through the 5 key points. Make sure that you are drawing a curve through those points and not just like a zigzag line going up and down, okay? So it does need to be a curve because there's no it's not a consistent rate. The rate of increase is slowing down as you get toward the top, and it levels off and then it drops again, okay? So there's no point up there. It comes to a smooth curve both at the top and the bottom. Of course, again, if I wanted to continue to add periods to this, I could do that simply again by adding a quarter of the period, or a pi over 4. Another pi over 4 would be at pi, and then what's that, 5 pi over 4, and then what would that be, 3 pi over 2, and then whatever another one was, 7 pi over 4, and 2 pi, and so forth. So if I keep adding a quarter of a pi, or subtracting, then we could extend this indefinitely, okay?